Okay, yes, we finally get to explore the properties of limits. Okay, so there are two types of limits, not two types, but there are easy limits and then there are limits in which we need to work with. Okay, so easy, quote unquote, kind limits, simple limits that we can just directly plug in and solve. And with these limits, we can use something called direct substitution. Right? I think I showed you one previously in which is x cubed plus 1, I think. And with that limit, we saw the question was what's the limit of x cubed plus 1 as x goes to -2. We can just plug in -2 into the function, and from that we found that that limit was equal to -7 just by plugging in -2 into the function. So we just plugged in -2 into the function and we got our limit. And those kind of functions, informally you can call them like kind or simple or easy to evaluate limits. Okay, so we're going to explore some properties that will allow us to find those limits quickly. Find those kind of limits quickly. Okay, so our first property here, number 1, okay. Right, the limit of a constant, and this constant, call it b. So the limit of b as x approaches c is going to be b, right? So, for example, the limit of 5 as x approaches any number, say -4. So the limit of 5 as x approaches -4 is going to equal 5, right? It's kind of obvious. Doesn't change. Remember that this is basically what? This function looks like this, straight line. So no matter where we go, it's still going to be 5. Okay, so here we go. So limit of x as x approaches c is going to equal c, right? So this is what x, the function f of x equals x looks like. So if we're approaching, say, if we choose -1 over 10, right? I mean -1 over 10 on the y-axis, and therefore limit as x approaches -1 over 10 is equal to -1 over 10. Is equal to -1 over 10. Okay, so pretty straightforward. Property number 3. If we have a constant in the function, we can take the constant, pull it out of the limit. Still the same. Okay, k is like any constant number. Okay. With 4, property number 4, if we have an addition or subtraction, this is just simply equal to each function evaluated individually. So you can break up the limit this way. Alright, and okay, let's move on. Property number 5 is going to be with functions multiplied together. So if we have f of g times, f of x times g of x, and we take the limit of that, that's going to be equal to each function evaluated individually, and then multiplied together. Dot. That's multiplication. Right, property number 6, pretty straightforward. Okay, now remember that this is called a rational function. Has f of x, a polynomial, over g of x, another polynomial. If that's the case, we can just take the limit of the top and the bottom separately. This is as long as this bottom is not equal to 0. Remember, you always have to watch out for that. So as long as limit of g of x as x approaches c is not equal to 0, this is okay. Property number 7. Now this follows directly from property number 5 in that if we raise f of x to a power such that we have f of x times f of x times f of x n number of times, and we take the limit of that entire thing, this is going to be equal to f of x, the limit of f of x as x approaches c, entire thing raised to the n power. So you just took this thing out. Same thing with this. We can actually do without this property, but just write like this, right? So if we, right, because this is basically what? This is basically a fraction. So if we take like the square root, or cube root, or quadratic root, n could be any number, we can just take that thing out. So that's equal to the same thing as this thing. Take it out, makes sense, follows from property number 7. Another thing to take note, right, follows from this one. So if a limit of x to the nth power as x approaches c, just simply plug in c into x. So it's going to be equal to c raised to the nth power. Oh yeah, for this one, this is true, common sense, but this is true for all f of x if n is odd, and it's only for, and this thing is only true for f of x greater than 0 if n is even, because you can't take an even root of n negative number. Okay, so with all these properties, hopefully you're not too surprised by them. So let's do a quick example. The limit as x approaches 5 of x to the 4th plus 3x cubed, entire thing, times x minus 1 squared. Okay, let me do this quickly. You can just follow along on the screen. Right, so we can break this up. And we're going to use something called direct substitution. So let's break up this first one now. We can factor out 3, right? No, we can take out the 3 and put it in front of the limit. Okay, this reads plus 3 times the limit of x cubed as x approaches 5. Okay, and this took this, I just took this squared exponent and I just moved it outside of the limit. We can do that, right? And we just plug everything in, so we plug in 5. Minus 1 equals 4. 4 cubed, sorry, 4 squared equals this, and this equals 11,200. Right? We could have just simply plugged this thing in. That's basically what we did, right? We just plugged this in. But I did all this to show you how to use the properties, which are pretty self-explanatory. So this is called direct substitution. And we can use this with all polynomials, which I called kind or simple or easy at the start of the lesson, right? So all polynomials are kind and easy in that we can just directly substitute them in. Okay. All rational functions are also kind to us. All rational functions. are also kind to us in that we can just simply plug it in. Alright, looks like the computer has some problems. Wait. Anyway. Okay, so the computer had some problems there. Hopefully it doesn't show, but we'll take a look at how it looks. Okay, so rational functions, same story here. It's this rational function, remember, with rational functions we have a polynomial over a polynomial. Right? And we can just simply do a direct substitution with this, as long as it's not equal to 0 and 5%. You know what? Let me write this in a more clear manner. Right, so if we have this thing here, a limit as x approaches c of this is just simply this thing over this thing, p of c over q of c, as long as q evaluated at c does not equal 0. Okay, so let's do an example. This is all pretty straightforward, so hopefully you should have no problem with this. So limit of x cubed minus 5 all over x squared minus 5 all over x cubed plus x is going to substitute this in 1 over 10. Alright, we do have some time left, so let's continue. Okay. Composite functions. The limit of a composite function. This is kind of confusing, but stay with me here. Okay, this basically states that if the limit of g of x as x approaches c is equal to a, and the limit of f of x as x approaches a is equal, and if this limit is equal to basically direct substitution, then the limit as x approaches c of the limit of f of g of x as x approaches c is going to equal f of a. What the world? Take a look at this. So basically it's telling us that if we evaluate the limit of the inner function and it approaches a, and if the limit of the outer function as x approaches whatever the inner function is equal to, which is a, and if this if this thing exists, then it's going to equal f evaluated at a. It's more confusing than it needs to be. Let's take a look at this. So say we have the function, say we have this function here. It's a composite function, and that g of x is going to equal, the inner function is going to equal 3 times x cubed minus 16, and the outer function is just simply going to be 5 root x. Alright, so and the question that we have is, what is the limit of, you know what? I messed up again. F is on the outside. Okay, so what is the limit of f of g of x as x approaches 4? Okay, so let's take a look at this. So since this limit what is this limit equal to? This limit is equal to it's just going to be a simple substitution, like that. right? So that is going to equal 32, right? So now we have 32. So this inner function is going to approach 32, and therefore it's going to be like this, right? No, sorry. Sorry. What we're going to get is, since this inner function is going to approach 32, the limit of the outer function now is going to be limit of f of x as x approaches 32, and we can simply plug it in. And we get, 2. Do you see that? That's a composite function. So therefore, we're taking, we take a look at what the inner function approaches, and we use that as a limit of outer function. Okay, that's that. Oh yeah, and one more quick thing. Running out of time here. All trig functions are kind in that we can directly substitute them in. Right, so in that, what I mean by that is the limit of sine of x as x approaches c is going to simply equal sine of c. Same thing for cosine. For secant and tangent and cosecant and cotangent, it's everywhere where the function is defined. So for secant and tangent, it's everywhere where cosine is not equal to 0, and for cosecant and cotangent, it's everywhere where sine of x is not equal to 0. Okay, so everywhere else, wherever the function is defined, you can just use direct substitution with those trig functions. Okay, and a is any constant, so with the exponential function e to the x, or a to the x, a is any constant. I said that before. For all x, you can directly use direct substitution. You can just use direct substitution, and the same thing for log and ln of x. You can just use direct substitution. For x is greater than 0. Remember that these functions are only defined where x is greater than 0. Okay, so I basically told you the functions in which we can use direct substitution. Just simply plug the c value into the function, and whatever pops out is the limit of that function as x approaches c. You can do that for polynomials, for rationals, for trig functions, wherever it's defined, and for composite functions, I showed you how, and also for exponential and log functions. Whew, that was a long lesson. See you in the next one.